so cool looking. It was just this display of boxed, framed in the box shirts with a matching tie and a tie clip.
Wow.
And it was just, it was a 3-piece thing, all cut perfectly presented in a box, and they had different colors and different patterns, and like it was just almost like an outfit in a box. Like with men's outfits, you really just need one pair of pants, or 2 pairs of pants, and you have such a variability. What do you call that? Anyway, the math term
for
when you add never mind.
Probability, like when you
not like probability, but not unlike probability. It's a P word. And then there's a C word that they can mean similar things, but they're different in how you tabulate how many. Oh, it's just right on the tip of my tongue.
Yeah, keep describing it though. That's okay. It's instant. Yeah, say what you have.
I have 3 red marbles and 4 blue marbles.
Yeah.
Permeabilities. No, not permeabilities.
Oh, permutations.
Permutations.
Yeah.
There it is.
Nice.
Permutations.
Permutations.
Permutations of a suit with those sorts of things.
Yes.
Frig, that took me so long to get to that word.
Yeah. Well done. Permutation.
I remember that distinctly in my more recent math work. It's like going over permutations versus combinations and permutations. It's just similar.
Permutations and combinations. That was the distinction. Interesting. Good distinction.
And how do you calculate how many permutations or combinations? You can have particular kinds of things as arranged. And I've used that kind of math for gambling. Well, not gambling, but for variability in game theory. Elder Torres specifically.
Okay.
Yeah, I wrote a big old math project up on it.
Oh, really?
Yeah.
Cool.
Anyway,
what was the math project?
Who would be against which elder gods are the best combinations of investigators useful?
Okay.
So if you are fighting Cthulhu and you have 2 players, you should have these 2. And these are the 2 people with whom you will win the most often. But if you're 3, it might be a different permutation or combination of the 8 or 12 players.
Which players you should use.
Just depending on the elder god and its particular strengths, and the players and their particular strengths,
and especially their complementarity.
Exactly.
How they fit together as pieces.
And when you have so many different variability of players, because you have 12 well, you don't have 12 permutations. I forget how many permutations you can have within all that. Because you can have 1, or you can have 8 of the 12 original. And then you need to take into account all the expansions. It gets super complicated.
Interesting.
But there was math formulas that I was kind of putting together to find, and I made some pretty substantial conclusions based on data that I found online.
Yeah, neat. On which ones you should use for when. Okay. Cool. Do you remember any of them?
Not offhand, but I have the whole thing on my computer. The person who was marking it was just like, this was not expected. Most people do something that's kind of like benign, but easy. Just like you went outside the box and found something in a box.
Well, but then it's a great example of using math to relate to your actual world.
And I played that game a fucking lot.
Exactly, and to use something that you're familiar with. It's something that we really underwrite with math. We really get where we think that there's a Christmas tree up in that.
Weird.
We really feel like math is all about secrets, and there's special people who know the secrets, and then they can do the cool stuff with it. And then if you try really hard and make your brain do stuff that it's hard to do, then maybe you get to see part of those secrets too. But I think it's not actually that much secret based, and that it's certainly not the accessible, useful math, the math that we interact with and that enables and ennobles us the most, is not so secretive, and it's much more about it's much more about just relating that mathematical process to your own real experiences that you see, and that's how you understand the concepts. it's not the capacity for you to be able to contort and distort your brain to imagine complex things that somebody else has imagined. It's the ability to take this funny, quirky little universal idea that seems to fit in everybody else's ideas, and then to look at it through your own perspective in your own world and figure out how it fits with yours, and then it instructs you on how your world works. And we keep thinking that by taking this little thing we call math, there's something inside of that math that is able to do that. But it's not that at all. The magic is the world itself that you're then like tracing that on top of, and it's through doing things like that you start to realize that true nature of math, which is that it's not the formula that's so fancy in what it does. It's the fact that the formula is so reliable, and that even that formula, when used in its rightful and logical way, manifests as a truth within your own reality, of which you needed nothing else other than that little piece outside. And so sometimes we think that like all of the specialness there, it's like a magic wand that you wave over something, but the thing itself is what's magical. It has all the magic powder inside of it, our reality. It's the math is just like the lens that you get to look at it through, you know. And so taking it into your own world and ways that you've interacted with numbers before, and using math to understand that's how you learn, and that's how math empowers you, because it opens you up. It's the misnomer about math is that that math has these little nuggets of gold that you can then bring in. No, it only exposes gold. It's like a brush for the archaeologist. It doesn't contain any of the dinosaur bones. You have to know where the dinosaurs are and then dig them out with the brush. But the math is the brush.